Hi, I'm Dennis Chung from Jones Engineering Company Limited in Hong Kong. We're a ComAp's distributor for China. Today I'm going to share with you my experience for ComAp's synchronizing while engine speed is unstable. First of all, just to show you, ComAp has a online training on the website, which you can look at this address. Under genset synchronization principles, you will find this training in English, also I believe in Spanish and Italian. So please do go to ComAp's official website for the complete training on how to set up completely the synchronization. ComAp also has a YouTube channel, ComAp Control Systems, that you can search and subscribe in YouTube. If you want to look for my company, you can look for my company in LinkedIn under Jones Engineering Company Limited, or my website, jones.com.hk. If you want to make comments, you can make comments in YouTube and also can leave me a message in LinkedIn. So, I was testing two 500 kVA rental gensets under island parallel situation, meaning there's no mains, only the set and the two sets are parallel together, there's no mains connected, using ComAp's IGNTC BB controller with an IntelliVision 5 color display. So you can see these orange gensets working outside the factory. And the customer was wondering why the gensets were so difficult to synchronize. They were having trouble getting synchronization every time. Now, you can see when we look at one of the gensets, the genset in the rental fleet, this is G508 of the rental fleet. And you can see when I play the video, how the speed and the load is fluctuating, mostly because the load is fluctuating, thereby the speed is going up and down. So let's play the video. You can look at the RPM and also the engine kilowatts. The rest is Chinese, but of course, if you just look at the RPM and the kilowatts, this should explain it. So you can hear the engine was hunting. I was looking at it at this few seconds. It was going from 1477 to 1538 RPM back and forth. The load, of course, was going from 98 kilowatts to 170 kilowatts. We can't change the load. This is how the factory uses the load. The load fluctuates. It fluctuates a lot. Thereby, the speed would follow. So, the original settings that came when they tested the genset at the factory, the interesting points to look at are the voltage window, that's at 8%, which is okay. The dwell time, so this is the time. First off, the voltage window is the window, thereby the two gensets have the same voltage, so 8% difference between the genset voltage. Dwell time is the time when the two sets are in the voltage and the phase window. How long will it have to be inside the window before it sends a breaker closure signal? So the dwell time is 0.4 seconds, which is quite fast. That's okay. What I didn't like to see is the phase window of 3 degrees. What this means is the two sine waves of the two gensets, they have to overlap within 3 degrees for 0.4 seconds before we will send a synchronous signal, so thereby we will ask the breakers to close. Of course, 3 degrees when the engine speed is going up and down like that, that is not going to happen very often, that we can hold 3 degrees at 0.4 seconds. When they tested the engine in the factory, they tested on, of course, on a water brake or a dummy load, which is resistive, so everything is stable, the load was not fluctuating, and at 3 degrees, the breakers would close very peacefully and nicely. That's why they set it up like that at the factory, but when you run it on the site, things are not always so ideal. If you take a look at the default ComAp settings, on the left-hand side, you can see the default ComAp settings. If you look at it, the voltage window by default is 10 degrees, and the dwell time is 0.3 seconds. And then but the phase angle, the phase window that we set from ComAp, from factory set at 10 degrees, which is quite a bit wider than 3 degrees. But anyway, the settings on the genset on site was at 3 degrees. So while I was on site, I didn't look at the default ComAp settings, so I went on to change the settings. Namely, 8% voltage window, from my experience, is fine. 8%, 10% is not a big difference. The phase window, I changed it to 9 degrees. For myself, I typically like to set it 8 degrees, but 8 degrees, 9 degrees, 10 degrees is not a huge difference. You need some angle for this to work. And I wanted the dwell time to be shorter because the engine was going up and down in speed, so I didn't want it to hold for too long, so I shortened it to 0.2 seconds, as you can see in my settings. So these are my settings. Now, we can see after I changed the settings, G508 is online. You saw how it was hunting up and down. So I take a video of G507. That where I push the button, it is a closed GCB. And you can see from the video how this works. So you can see when the button I press, after I press it, you see it blinking. That is when it's trying to look for the synchronous point. You will see ComAp does try to push the G507 towards 12 o'clock, the synchronous point. When it reaches within 9 degrees for 0.2 seconds, it sends a close breaker button. You hear that click. That is the breaker closing. You can hear that, and then immediately afterwards the gensets start to load share, and you can see I showed you that the load sharing is quite even between the two sets. So to make the test complete, of course I need to test the other way around, so I took G508 off the bus. So only G507 is running now with the same settings, 9 degrees, 0.2 seconds. I tried to close 507 to 508. So we look at video here. So you can see that works quite well. The both synchronous time was about 8 to 10 seconds roughly. You can time it, which is not bad. I mean, the engine is fluctuating a lot. It's not very stable, so it does work very well. So, conclusion. When you need to synchronize with unstable speed, of course, ComAp would help you and it will perform very well. Probably by the default settings from ComAp, it works well already. You probably didn't even need to make much difference. If the engine was more stable, I can tune it so it's more peaceful when it synchronizes, a bit narrower angle, longer dwell time. But if the engine is fluctuating so much, I think the default settings, it should work. Probably don't even need to touch it that much. Now, of course, very important thing, make sure you have a very fast breaker. If you want to synchronize gensets, don't use a cheap slow breaker that takes to go. Those days are gone. We have very fast air circuit breakers today. Take a fast breaker. When we give the command to close, it would close immediately. Then everything would work. So again, the ComAp website online training, the address is here. The YouTube channel ComAp Control System is here. My LinkedIn, you can add me. You can make comments here. If there are other things about ComAp that maybe you didn't find in ComAp's training, you can leave a comment. Either I will do some training to try to explain it, or ask ComAp to do some training to help everyone. So I hope you like this video. Thank you very much. Goodbye.